now let's move on to very fundamentals of statistics. So the very first one would be the mean, the average of individuals. Mean is often represented as bar x, and we calculate it by the sum of data values divided by the number of data values. And in our equation, it's represented as sigma xi, which means that x1 plus x2 plus dot 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 divided by n. And there's a difference between statistics and a parameter. Statistics are the numbers, like the numbers that we use from a sample. And the parameter are the numbers that we use in a population. So for mean, when we use it in a sample, we use it as a bar x. But when we use it for a population, we use it as a mu. This mu is something that's same as coefficient of coefficient of friction in physics. They look the same, but they're totally different concepts, so just don't get confused. The second one is the median. Median is like the midpoint of distribution. So when you have like 5 datasets such as A1, A2, A3, A4, A5, then A3 would be the median of this number set. And when there's a dataset A2, A1, A2, A3, A4, then the average of these two, which is going to be A2 plus A3 over 2, would be the median. So to make it simple, if the number of values are even, then you simply just divide the number with 2, and that number would be the median. I mean, not that number, but the number located in that order would be the median. So for example, I think I wrote this note wrong. This should be the opposite. My bad. When n equals odd, this is the median. And when n equals even, this is the median. And this expression is also wrong because we're not dividing n by 2. We're saying that when there's n number of them, then x2 or n plus 1 over 2 would be the median because, for example, they have 5 numbers over here. So x2 over 5 plus 1, which equals x3. I mean, in this part, they're represented as a, but I'm just making it general, so I'm representing as x. And when the n is even, then it's just simply average of two middle value, which would be a2 and a3. Now let's talk about the skewness of mean and the median. So when a graph, which I refer as a dot plot, when the dot plot is skewed right, median is smaller than mean. But when it's skewed left, mean is smaller than median. And so if I represent it on a graph, let's just say there's a graph that is skewed right like this and skewed left like this. So when the graph is skewed right, mean is bigger than median, I said, right? So the median is going to be here. But the mean is going to be somewhere over here. And when it's skewed left, it's opposite because median was going to be over here, but the mean is going to be over here. And these are not an absolute thing because they are just expected to be like that. If there's an irregular form or if there's an outlier, it can change also. The next vocab would be the range. Range is simply the maximum value minus minimum value. If you have a data of like the average height of United States men, and the minimum is 125 and the maximum is 200, then it's going to be 200 minus 125. And the next thing is the standard deviation. Standard deviation is the typical distance of values. So to represent this as a drawing, let's just say this is the average height, something like 178 centimeters, or we often call it as 5'10". So if this is 5'10", and there's like people like these kind of height of people, right? like 169, 174, and blah 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 blah. And the standard deviation is the average of these differences of the so it's the average of difference between the data and the mean. This part, 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 and all these parts. The average of total all these datas are the standard deviation. So we often represent standard deviation as Sx. And this is for the, what do you call it, the sample statistics. And when it comes to population, we call as this. But anyways, the formula of the standard deviation would be the sum of each value minus mean value to the square divided by n minus 1 to the square root. And how this formula is made, it's not really necessary to be explained. But yeah, you just gotta look at your textbook for this. And there's a standard deviation of this, which is the population standard deviation, and they have a slight different formula. For this one, n minus 1 changes into n. It just changes to n, so you just don't do -1. The next one we'll be learning about is the quartiles. So for Q1, the first quartile, Q3, the third quartile. The first quartile means the median of data values on the left of the median. Third quartile means the median of the data values on the right of the median. And this is going to be the 25% point of the data. And this is going to be 75% point of the data. So for example, if the median is 50%, this is going to be 25% and 75%. And the interquartile range, which I explained right next to it, is just simply Q3 minus Q1. Now let's go a little bit deeper about the outliers. So outliers are like the irregular data values that we find in our dataset. And there's a low outlier and a high outlier. Low outlier means that it's too low. It's just so low. And high outlier, means it's just too high. And they both like make an irregular numbers. So the low outliers are the ones that are smaller than the first quartile minus 1.5 times the IQR. And the high outliers are the numbers that are outside third quartile plus 1.5 times IQR. In the 5-number summary are putting median, Q1, Q3, and minimum and maximum. It's called 5-number summary because we're using 5 numbers. So for the 5-number summary, we check the minimum, maximum, the median, Q1, and Q3. And this over here is the domain for outlier. So if a data goes outside this domain, then this is considered as low outlier. And this one would be called as high outlier. So, yep, that's all for today's lesson. And I'm going to come back with AP Stat Unit 2 next time. Have a great day, and thank you for listening.